Howdy! Welcome to Aspire Mountain Academy. I'm Professor Curtis, your instructor for this course in Introductory Statistics. In less than 10 minutes, this video describes random variables, including the differences between discrete and continuous random variables. Let's get started. So a random variable is just a variable with a single numerical value determined by chance for each outcome of a procedure. And like most variables that we have in mathematics, we're going to represent them with a letter, and the letter that's most often chosen is the letter X. Now, random variables come in two flavors. There are discrete random variables, which, like discrete data, there's a finite number of values or countable number of values. Okay, so there might be an infinite number of values, but that result from a counting process. So generally, discrete random variables are going to be whole numbers, just like discrete data. And then, of course, the other flavor we have is continuous random variables. There are infinitely many possible values, and they may be whole numbers, they might not be whole numbers, just like continuous data. Okay, the values are usually associated with some type of measurement on a continuous scale without gaps and interruptions. So just as we learned in an earlier mini lecture about discrete data and continuous data, that same difference is going to apply to random variables. Let's engage a short little quiz to test our knowledge of what we just learned about random variables. So we're going to look at some examples, and for each one of these examples, I'd like you to tell whether you're looking at a discrete random variable, a continuous random variable, or not a random variable at all. Here we go. First up, we've got the distance the average driver travels before refueling his or her vehicle. What say you? Discrete random variable, continuous random variable, or not a random variable? I'll give you a few seconds. Well, I hope you said this was a continuous random variable. Distance, as we know, is a measurement of length between point A and point B. And so distance would be an example of continuous data, and hence would be an example of a continuous random variable. How about the number of light bulbs needed each year to replace burnouts in a selected store? Well, I hope you said discrete random variable. This is an example of discrete random variable because the number of light bulbs, you're counting whole numbers, and only whole numbers, and so that's discrete data, making this discrete random variable. What about the average number of minutes a light bulb lasts before needing replacement? Okay, this is an example of continuous random variables. So the average number of minutes, that could be anything. It could be a whole number or not a whole number. So that's an example of continuous data, making this continuous random variable. What about the responses to the survey question, do you support the proposed bond measure? Well, I hope here you said that this is not a random variable. Responses to the survey question, do you support the proposed bond measure? That's not going to be discrete or continuous data, because discrete and continuous data are examples of quantitative data. What we have here is an example of categorical data. Do you support the bond measure? Yes, no, maybe, not sure. These are examples of categorical data. And so, because it's categorical data, the responses to the survey question are not random variables. You have to be quantitative data in order to be a random variable. So categorical data do not qualify to be random variables. What about the amount of water contained in a popular brand of bottle? Well, here we've got an example of continuous random variables because the amount of water is continuous data. It could be a whole number, but it could also be something in between whole numbers. So that's continuous data, making this continuous random variable. What about the average number of ice cream scoops a customer orders on a waffle cone? Oh, now I'm getting hungry. Maybe I'll go get me a waffle cone while you come up with your answer. Well, actually, it shouldn't take you that long to come up with the answer. I hope you said continuous random variable. The average number of ice cream scoops. So the average number could be, a whole number, or it could be something other than a whole number. That's continuous data, making this continuous random variable. How about this one? The number of ice cream scoops a particular customer orders on a waffle cone. Here we've got an example of the discrete random variable because the number of ice cream scoops is going to be counted in whole numbers. You give me a partial scoop of ice cream on my cone, I don't care what kind of cone it is, man. I'm going to say you cheated me. I want a whole scoop, man, whether it's 1, 2, 3. I think 3 is the most I've ever had on an ice cream cone, but I don't know. Waffle cone, I might be able to go to 4 or 5. It kind of depends on how big the scoops are, how big the cone is. This is getting me hungry. Maybe I should go get me a waffle cone. Well, that's going to be the end of this mini lecture because, I need a waffle cone. So I hope you found it helpful. You can find more mini lectures for this and other courses at AspireMountainAcademy.com. Thanks for watching. I'll see you in the next video.